Hello and welcome to a new lesson. In this lesson, we will start our journey with a system health and performance monitoring project. We will begin by updating the system on Rocky Linux virtual machine. So let's type sudo yum update. Next, we will install Htop and sysstat. So let's type sudo yum install Htop sysstat. As you can see, I already installed the Htop and sysstat on this system. In this lesson, we will focus on Htop. In future lessons, we will discuss sysstat. But for now, let's execute Htop. Htop provides insights about your system. From the Htop output, you can see that this system has two CPUs, and it also shows the CPU utilization of each CPU. Htop displays information about the memory and the swap, showing the total memory and swap and their usage. You can also see the load average and the system uptime. There are two tabs in the Htop interface, the main tab and the input-output tab. The main tab provides information about running process on the system, showing process ID, the user running the process, virtual memory, and reserved memory, CPU and memory utilization for each running process that shows the percentage the process is consuming from the CPU and memory. Under command, you can see the running command or process. You can also manage Htop through function keys. For example, you can quit Htop by pressing F10, terminate or kill a process with F9, and sort the output by F6. Let's press F6 to sort the output. As you can see, we can sort by process ID, user, CPU, and memory percentage. Let's sort by memory utilization, so I will select %_mem. Now press enter, and as you can see, Htop now sorts the output by memory percentage. Now let's simulate a memory leak using simple Python script I have developed for testing purposes. Don't execute the script in a production environment. Test it in a playground environment to learn. Let's go to another tab and let's execute ls. Here is the Python file I will execute, mem_leak.py. Let's view the file's content. So let's type cat mem_leak.py. This Python code will consume 1 megabyte of memory with every execution of the script. The script will run indefinitely because it has a while true condition and waits 1 second between each execution. To execute the script, type python 3 mem_leak.py. Now let's return to the htop command. Since we are simulating a memory leak, ensure that the output is sorted by memory percentage, which we already did. As you can see, our script is now displayed under command. And from the user, you can identify the user running the script or process, which is, in our use case, user Vagrant running the process Python 3 mem_leak.py. You can also see the memory percentage is increasing and that memory usage increases every second by 1 megabyte. Now, if you are on a system running Htop and notice a process consuming memory, what should you do? First, ask yourself if this is a normal process. If it is, investigate why it consumes memory. Does this process or service need optimization to consume less memory? Optimization is not always the solution, as it may lead to poor performance. However, this is something you will learn through trial and error. If the service such as a database service or web server can be optimized, do so. If it affects performance, you may need to increase the memory for your virtual machine or physical server to solve the problem. What if the process consuming memory is a one-time process, such as one running for a specific job for a period, and it causes a memory leak? In this case, see if the process can be optimized or not. You may find yourself terminating the process and stopping it until you fix the problem. Otherwise, the process may be malicious. In that case, terminate it immediately and investigate how it was executed on your system to prevent recurrence. Now let's execute multiple processes from multiple leaks to simulate how dangerous a process consuming memory can be. Go to the tab where the memleak script is running and press Ctrl C to terminate the process. Now let's execute ls, and I have a shell script here named run_mem_leak.sh. Let's view the content of this script. So let's type cat run_mem_leak.sh. As you see, this bash script has a for loop from 1 to 20 and executes memleak in the background, running memleak 20 times in parallel. Let's edit the bash script to run the script 100 times. So let's type vi, then run_mem_leak.sh, and I will change the for loop to be 100. Then I will save the file. And by the way, this is very dangerous and will cause the lab 1 virtual machine to become unresponsive. So don't test this script on a live system. Just test it in a playground virtual machine where you don't care about the consequences. So now let's execute the script. So I will type bash, then run_mem_leak.sh. Let's go back to the Htop tab. You can see the process mem_leak everywhere with a spike in memory usage and the system starting to consume swap. There is also a spike in CPU usage. If you troubleshoot a system and find a process consuming both memory and swap, something is definitely wrong with that process. The system will terminate this process automatically to protect itself. But if the process restarts or recreates itself automatically, the system will eventually crash. As you can see now, the system is unresponsive because the process consumed all the memory and swap. Now I will try to execute the pkill command in the other tab to kill the process. If it doesn't work, I will have to reboot the virtual machine. So let's type here pkill, then Python 3. And as you notice, it takes some time to type because the system is not responsive. Now let's press enter. And I also pressed enter and the system is not responsive, or it's very slow. So I will wait for maybe 1 minute to see if it will respond back or not. So it took like 30 seconds to finish the command or to execute the command. Now let's go back to tab 1. It seems the pkill command terminated all Python 3 processes and the system is back to normal. Now let's see how we can terminate a process from Htop. So let's go back to the second tab and let's execute mem_leak.py. The process is now running. As we can see here, we can see the process under the command. To terminate the process, select it, then press F9 and select the signal. I will select sig term. Now press enter to send the signal to the process. As you can see, the process is no longer shown. Let's check the second tab. As evident from the output, the process has been terminated. Returning to the Htop tab, to exit Htop, let's press F10. If you suspect that a system has or had an issue with memory, you can detect that from the logs. To detect memory issues on a system, execute sudo cat/var/log/messages, then pipe that to grep memory. If you see out of memory in the output, know that a process is consuming memory and the system terminated it to protect itself. The output shows which process caused the out of memory issue and has been terminated. When you see a process causing out of memory, investigate the process to determine your options. Is it a process that can be optimized, a process that needs to be terminated and ensured it won't run again, or a normal process that can't be optimized and needs more resources? In this case, you may need to increase the system memory. And with that, we come to the end of our lesson. Thank you for watching and see you in next lesson.